We're going to review multiplying matrices. If we have matrix A given here, matrix B given here, we're asked to find B times A. Now remember, when you're multiplying matrices, the order matters. So we're asked to find B times A. I could write that here as 1, 6, 2, 7, okay, times 1, 2, 0, 3. If you recall, whenever we did this, pause the video, attempt it yourself. If not, I'll explain it in the coming steps. So what we're doing here, so remember what we do here is we take the first column in the second matrix, in this case 1 and then 2, and you imagine kind of lifting it and bringing it over, and then what we're going to do is we're going to multiply 1 times 1 plus 2 times 2, which will give us this is our first row, first column entry in the resulting matrix. We then continue that, lift the first column, and we continue this multiplying through all the possible rows of the first entry. So that will give us the next entry. That'll give us the next entry 1 times 6 plus 2 times 7. And then we see that we have multiplied this column through all the possible rows of the first matrix. So next we turn and we think about lifting the second column. So now we look at the second column and we're going to imagine lifting it, bringing it over here, and then we're going to multiply each entry as follows. So 0 times 1 plus 3 times 2 will give us the entry, will give us this entry. Next, we take this column and multiply it by the next row, which will give us the entry here. Now, all it is left is to actually compute these, find these sums, and then rewrite it as our final answer. So, simplifying these expressions, we find our resulting matrix, B times A, is as follows. Okay, so that's just a quick review on matrix multiplication. Next, we're going to look at our next topic, which is the inverse of a 2 by 2 matrix. Now, in class, we learned how to do this in two different methods. First, we learned how to do this through row reducing and augmenting with the identity matrix, and then we learned a helpful formula. So let's start first with the quick formula that works, especially when it's a 2 by 2 matrix. We'll call that our method 1. Okay. So remember, when you have a 2 by 2 matrix, we'll say B equals ABCD. Then B inverse is going to be equal to this scalar, which is found by taking AD minus BC all over, 1 over that, times this. On the main diagonal, we just switch the entries, so it's D and then A. And then on the off diagonal, we just apply a negative. So we just change it to an opposite sign. So for our problem, we have that A equals 6, 1, 5, 2. Okay. So we know A inverse following this formula will be 1 over A times D is 6 times 2 minus B times C, 5 times 1. Times, and now we switch the order of the main diagonal, so a 2 and then a 6. We change the sign for the off diagonal, so negative 5, negative 1. Okay. Now we just have to do a bit of simplification. A inverse is then equal to, simplifying this difference we get 7, so it's 1 divided by 7 times this matrix. You can leave it like this, or you could bring the scalar throughout the matrix. Remember, when you multiply a matrix by a scalar, you just multiply each entry of the matrix by that scalar. So we get 2 sevenths minus 1 seventh. 6 sevenths. Okay. Finally, remember, you can check that these indeed are inverses. We should be able to take A times A inverse and get our identity matrix for the 2 by 2. Or A inverse times A, we'd still get our identity. So as a good practice, you might take A and A inverse, multiply them, and see that we would get the identity in this case. Now we're going to attempt the same problem, but with a different method. And particularly this method is helpful as we extend to maybe a 3 by 3 matrix, finding its inverse. So in this different method of finding the inverse, we will write down the matrix. Okay, then we draw a vertical bar, and here we write the identity matrix. Okay. Now our goal is to do row operations to turn the left side into the identity matrix. All the while, we're keeping track of the changes here, and then what's left over in here will be our inverse matrix. So let's start that. As we're trying to get 1, 0, 0, 1 here, we see that we might be quickly solved by just switching row 1 and row 2, and we'll immediately get a 1 in the first row, first column. Okay, so that would give us 1, 2, so we've switched all of row 1 with all of row 2. Now we know our next goal is we want to make this entry a 0. So one way we might do that is we could multiply row 1 by -6 and then add it. So we'll write that down as our next step. Feel free to pause and work through this if you're recalling what we would do next. So what we're going to do is -6 times row 1 plus row 2 will be our new row 2. So we'll write that out here. So just to help keep track, I wrote out -6 times row 1. We're now going to add that as it's asked to row 2, and we'll get our resulting matrix -6 plus 6, 0, -12 plus 5, -7, 0 plus 1, 1, -6 plus 0, 0. Okay, and then we revert back to our original row 1. Okay, 1, 2, 0, 1. Okay. Next, we know that we would like to get this to be a 1. Okay, we could easily do that just by multiplying by the opposite reciprocal, multiplying by -1/7 here. So let's do that in our next step. So we're going to have -1/7 times row 2 equals our new row 2. So we'll have 0, 1, -1/7, and then 6/7 as the result there. Okay. We've almost got the identity matrix on the left side of the vertical line. So the last thing we'll want to change is we know this should become a 0. One way we could do that is by taking -2 times row 2. Let that be our new row 2 for now. And then in the next step, we will add that to row 1, and we'll get the 0 here that we're looking for. So let's multiply -2 times our new row 2. Okay, -2 times -1/7 is 2/7. -2 would give us a -12/7. And next we are going to say row 1 plus row 2 is going to be our new row 1. Okay, so let's add those together. So adding row 1 and row 2, we get 1, 0, 0 plus 2/7, 2/7, and then 1 plus -12/7. Off to the side, we could do a bit of scratch work to find this, rewrite 1 as 7/7 so we can add the fractions, and we would get a -5/7. Okay, and then remember we only changed row 2 to change something in row 1, so we'll revert back to our old row 2, so 0, 1. Okay, and -1/7 and 6/7. So from this, we see that since this side has become the identity through row operations, we see that what's left here becomes our A inverse. Okay, so we write our final answer. A inverse is then 2/7, -5/7, -1/7, and 6/7. So notice we got the same answer because we just did the same problem in 2 different methods. And this is the method that we're going to extend to finding the inverse of a 3x3 matrix, which we'll see in our next example. So this example was taken from our notes, so I particularly recommend you work through it on your note packet. This is at the end of 9.7 notes. So we're asked to find the inverse of a 3x3 matrix. So we'll use the method like we did in our previous example. We first begin by writing down our matrix. Careful not to introduce copying errors. Okay. Since this is a 3x3 matrix, we draw our vertical bar, and then we write the 3x3 identity. And our goal is through row reductions to make this matrix look exactly like this matrix. Okay, then this side of the vertical bar is going to be keeping track of all the changes. So then we'll find our inverse. We will actually finish this problem in the next video. So try to work it out yourself, and then to check your work, look at the next video that will be posted where we'll go over this and the final idea that we covered in 9.7 notes.